Hello and welcome. Today we're going to be looking at linear function word problems as part of the Heart of Algebra on the SAT math portion. As always, we're going to be looking at 5 questions and their explanations as we dive into the intricacies of this topic so that you can ace the SAT math portion. If you like this video or found it informative, please be sure to like and subscribe. And with that, let's get started. Question number 1. A zoo monkey is on a diet of fruit and nuts. Fruit has around 12.8 grams of sugar per cup. Nuts have around 4.0 grams of sugar per cup. The monkey ate 90 grams of sugar today, and we're asked to find which of the following shows the cups of nuts the monkey ate today as a function of the number of cups of fruit it ate today. Well, let's see. We can define the number of cups of nuts as n, and the number of cups of fruit as n. And for every cup of fruit, we have 12.8 grams of sugar. So we can write the total number of grams of sugar from the fruit as 12.8 F. And we can write total number of sugar from the nuts as 4.0 N, or just 4N. And then we add these two together, and that's our total sugar, and this is going to equal to 90. All right, now we want this in terms of N, right, or N of F, which is kind of the same thing. So we subtract out the 12.8 F and we get 4N equals 90 minus 12.8 F. And then we divide by 4 to get N, or N of F, same thing, equals 90 minus 12.8 F, 90 minus 12.8 F, F, all over 4. And looking at our answer choices, that seems to be this one right here. So our answer is choice A. Let's move on. All right, question number 2. Here it is. From the age of 1 to the age of 4, Richard's dog Spot gained weight at a linear rate of 5 pounds per year. So I'm just gonna scribble this down. 5 pounds per year. Spot weighed 8 pounds on his first birthday. Which of the following linear equation shows Spot's weight W at y years of age for 1 less than or equal to y less than or equal to 4? Well, let's see what we can do. We can write W equals, well, you start at 8, and then you get 5 for each, or no, you start at 5. Wait, okay, now I'm getting confused. You start at 8 pounds on his first birthday, and you get 5 pounds per year. 5 pounds per year. But he has 8 pounds on his first birthday, meaning that we have to subtract this 1 here. Right, so that on his first birthday, he starts off with this part goes away on his first birthday, and he just left with 8. On his second birthday, he has a 13, and then 18, and on and on. And that would make our answer be choice B, and we are done with that question. Let's move on. All right, question number 3. Over the course of 4 years of training for the 100-meter dash, Erica's best time at the end of each end-of-year track meet improved linearly by 0.3 seconds per year. Her best time at her first end-of-year track meet was 13 seconds, which the following equation shows Erica's best time be after y years of training for 1 less than or equal to y less than or equal to 4. All right, so let's see what we can do here. So her time, right, so we can do the time, or we can just, and that's going to be 13 minus 0.3 seconds every year. Sure, let's try it. And it's 0.3 seconds every year. Let's see, but at her best time at her first end of year track meet was 13 seconds. So after a year, it was 13 seconds, not 13 minus 0.3. So then we have to do the minus 1 again. So now our answer is going to be choice A, and let us move on. All right, question number 4. A swimming pool with 30,000 gallons of water is drained by a commercial water pump. Every 3 minutes, the pump drains 100 gallons of water from the swimming pool, which of the following functions best models the amount of water W in the swimming pool after n minutes of pumping. Well, let's see. So you start off with 30,000, so W of M. Start off with 30,000, and then you track how much. Well, you lose 100 gallons of water for every 3 minutes. So in 1 minute, you lose 100 over 3 gallons every minute. And then multiply that by the number of minutes. So then our answer is going to be 30,000 minus 100 over 3. And this corresponds to answer choice D right here. And we are done. Let's move on to the last question of this series. And here it is. A 400-seat public theater collects $5 per theater goer, but does not collect any money from accompanying children under the age of 5. If children under 5 still require seats, which of the following functions best models how many dollars D the theater earns during a sold-out show with C children under the age of 5 in attendance? Well, let's see what we can do here. So you have 400 seats, but C of them are taken up by children. So you have 400 minus C people who are actually paying. So you have then the amount of money you get is 5 times 400 minus C. That's the amount of money. So D over C equals 5 times 400 minus C. And our answer then is going to be choice B. And we are done. All right, that is it for this set. Be sure to tune next time when we continue our study of the heart of algebra. Until then, this is our topic on linear function word problems. You've seen the problems. Now, the problems are relatively simple. We simply take the question and we transform it into an equation, just like we've been doing this entire topic of the heart of algebra. We've just been using our fundamental skill of turning the words into equations, into inequalities, and we're going to continue doing that in the rest of the heart of algebra. I'll see you next time.